Hello everyone. We were discussing this question. A block of 5 kg is being pulled horizontally with the help of a force of 2 newtons. Coefficient of static friction is 0.4 and coefficient of kinetic friction is 0.3. And aim is to find friction acting on the block. Look here, how to handle a question like this. Whenever they give you a question of friction, first thing, draw all the forces acting on the body. Downward force mg, normal reaction force vertically up, and since this 5 kg has a tendency to move this side because of the force, to oppose the relative motion with respect to ground, friction will act in this direction. These are the forces which are acting on this body, and we need to find now value of Fr. This is mg, this is n. This 5 kg cannot move vertically up or down, and therefore normal reaction is coming what? Mg. Imagine if the block is inside a lift which is going up, then you know that normal reaction changes. But right now this block is not going up or down, and therefore normal reaction is simply what? Mg. Why did we calculate normal reaction? Because we need to calculate Fr static maximum. Whenever you are attempting a question of friction, you will find these values. Fr static maximum. What was this? Mu s multiplied by n. Mu s is 0.4. Normal reaction is mg, n is 5, g is 10. This gives you Fr max as 20. That's your Fr max 20. Which Fr max? Static. And at the same time, let's find out Fr kinetic also. So this is Fr kinetic. Fr kinetic is not maximum, it is always same, and it will become clear with the help of this example only. Fr kinetic is what? Mu kinetic multiplied by normal reaction. Mu kinetic is 0.3, normal reaction is 5 into g, which gives us Fr kinetic as 15. Before we even find Fr, we always go for Fr maximum static, Fr kinetic. Question is, find out Fr, friction acting on the block. We haven't found friction so far, we have only calculated maximum of static and the kinetic. We have not calculated value of friction. अब सीखना इस क्वेश्चन को आगे किस तरह से हैंडल करना है. Pulling force is 2. Now what normally we will answer that F is 2. Pulling force is 2 newtons. We have found Fr static as 20. Immediately लोग इस Fr की वैल्यू को क्या पुट कर देते हैं 20. Fr static which is coming 20 लोगों ने उठाकर यहां पुट कर दिया. But now look at this figure. आपको खुद फील हो जाएगा कि चीज गड़बड़ चल रही है. क्या गड़बड़ चल रही है यहां पर? इस बॉडी को जितना फोर्स खींच रहा है उससे ज्यादा रोक रहा है. If you have a body and this body is being pulled in this direction with a force of 2. At the same time, you have a force in this direction which is of 20. Then, हर आदमी को पता है कि इस बॉडी के पास टेंडेंसी मूव करने की कहां डेवलप होगी? वेस्ट, बिकॉज दिस इज द डोमिनेटिंग फोर्स. तो अगर किसी ने इस 2 को अपोज करने के लिए यहां 20 लगाया तो सिचुएशन किस तरह की डेवलप हो जाएगी कि जो ब्लॉक है ये ईस्ट न जाकर कहां जाने की टेंडेंसी इसकी बनेगी? वेस्ट. दिस इज समथिंग विच इज नॉट पॉसिबल एट ऑल. व्हाई? इमेजिन दिस. यू हैव अ ब्लॉक. Now this block is lying on a horizontal surface and somebody gave you all this information, and then you come and you try to move this object, you try to pull this duster this way. Try to visualize this. You have a duster which is resting on a horizontal surface. Resting means it's not moving. आप आए और आपने इस डस्टर को कुछ फोर्स लगाकर अपनी तरफ खींचा, अपनी तरफ. बट अगर इस तरह का फोर्स ऑफ फ्रिक्शन जनरेट हो जाता 20 तो आप परेशान हो जाते. आपको लगता पता नहीं क्या हो रहा है. आपने 2 से अपनी तरफ खींचा. इंस्टेड ऑफ दिस ब्लॉक मूविंग टुवर्ड्स यू, व्हाट हैपेंस? इट मूव्स अवे फ्रॉम यू बिकॉज ऑफ दिस डोमिनेटिंग फोर्स. Now you all know that something like this is never ever possible. कि ब्लॉक रखा है, आपने अपनी तरफ खींचा, आपकी तरफ आया नहीं, चला कहां गया? आपसे दूर. This is something which is not possible at all. And therefore, this 20 is something which is not possible. That is the reason we say that friction is a self-adjusting force. What is self-adjusting? If this is 2, तो आपने आगे से इस मैक्सिमम फ्रिक्शन को अपने दिमाग में किस तरह से फिट करके रखना है कि एक 20 लोगों का एक ग्रुप बनाया आपने और उस ग्रुप से क्या बोला कि भाई इस ब्लॉक को मूव नहीं करने देना है. They need to keep this block at rest in static condition. 20 लोग कहीं बैठे हुए, एक ग्रुप है 20 का, and they have been given a task that this block should never ever move. But they are quite lazy. बहुत एक्टिव नहीं है, बहुत लेजी हैं. जितनी रिक्वायरमेंट होगी उतने ये लोग काम करते हैं. तो हुआ क्या था कि इस ब्लॉक को चलाने के लिए, मूव करने के लिए कितने लोग आए थे? 2. Force of 2 Newton. Let's say there are 2 who are pulling this block. जब 2 लोग इस ब्लॉक को खींच रहे हैं, only 2, और रोकने वाले कितने हैं? 20. And I said that they are very lazy. इस 20 में से पूरे 20 को आने की जरूरत नहीं. Their responsibility is to keep this block at rest, and therefore they only send 2 out of this bunch of 20. So 2 is the force of friction, 2 is the pulling force. This is 2, that is 2. 5 kg remains at rest. What is rest? Rest means static. And therefore we say that Fr static maximum. What is maximum? 20. But right now, what is the force of friction acting on the body? 2 only. ये चीज और क्लियर होगी यहां देखना. And let me ask this question first. Suppose instead of 2, I give you that this pulling force is 16. Pulling force is what? 16. Write down force of friction fast in the comment box. If instead of 2, pulling force is 16, then tell me how much do you understand this question now? Good. बहुत सही. तो अगर 16 इसको खींचने के लिए आएंगे तो इस 20 में से केवल कितने लोगों को आने की जरूरत है? 16. And body will remain at rest. अब मैंने डिफरेंट कलर से शो कर दिया. ब्लू एंड ब्लू, ब्लैक एंड ब्लैक. आपकी मर्जी, आप जैसे ही बनाना चाहें. Now, अगर ये 16 की जगह पर हमारे पास 20 होता pulling force, I don't need to ask you now because हर आदमी को पता है कि force of friction भी क्या बनता? 20. 20 का फोर्स इधर, रोकने के लिए कितने आ सकते हैं? 20. सारे के सारे पहुंच गए रोकने के लिए. जब तक ये फोर्स लग रहा है, फोर्स ऑफ फ्रिक्शन, यू कैन सी दैट दिस बॉडी रिमेन्स एट रेस्ट. सो व्हाट इज 2? Static friction. What is 16? Static friction. What is 20? Static friction. But what is 20? 20 is the maximum value of static friction, and you can see that static friction is adjusting its value depending on the pulling force you apply on the body. Note down this much and then we'll write a statement. Write down the statement. As long as pulling force does not reach a value of 20, 5 kg block remains at rest. Five kg block remains at rest. And since when a body is at rest, and since when a body is at rest, net force on it should be 0. Static friction acting on the block is always equal to the applied force on the body. Is always equal to the applied force on the body. And you can mention the whole thing in this form. If F, what is F? Pulling force is less than or equal to 20. As long as your pulling force is less than or equal to 20, body is at rest. And since body is at rest, Fr friction, which has a name, Fr static, will not write maximum. Friction, we'll call it Fr static because body is at rest, is equal to F only. तो अगर किसी ने 14 लगाया, अगर 14 लगाओगे बॉडी मूव नहीं करेगी. अगर F14 है तो Fr भी क्या होगा? 14. बॉडी विल रिमेन एट रेस्ट. होपफुली पार्ट क्लियर होगा. नाउ मैं इसी फिगर में कर रहा हूं, आप जहां भी बनाना चाहे वहां कर सकते हैं, और यू कैन कंटिन्यू विद द सेम सेटअप. आफ्टर दिस 20, हमने अपने फोर्स को 21 कर दिया. I hope you can see it. 21. I'm using a different color, red color. If you can see the color, this is 21. So if I make the pulling force 21, let's see who will answer how much friction acts on the body. If pulling force becomes 21, then how much friction is acting on the body? Write down your answer in the comment box fast. Good. Some of you have produced the correct answer. And removing this, we have the information of Fr static. And those of you who have answered 20, just look here. Fr static maximum, it was 20. the information present over here was this Fr static maximum. But look at this, Fr kinetic is what, 15. The moment you apply a force of 21, कितने लोग हैं इसको रोकने के लिए? 20. अगर ये पूरे के पूरे 20 भी आ जाएंगे, अगर आ जाते तो कंडीशन क्या बनती देखना. अगर ये सारे के सारे आ जाते तो इस तरफ कितना फोर्स लगाया अपन ने? 21. And suppose you thought that the force of friction is what, 20, and you still thought that this is a static one, जैसे कि आपने आंसर दिया है कुछ लोगों ने. तो प्रॉब्लम क्या हो रही है? कितना फोर्स है? 21. This is what, 20. I hope you can see that F total is no longer 0. There is a net force. This is a dominating force. This body is not at rest. It is moving. It is moving. And if it is moving, then this term, static, it makes no sense. And therefore, when F is 21, you're applying a force of 20, body is moving. If it is moving, we have to use Fr kinetic. So, this is not the correct answer. The moment you apply a force of 21, मैं इस 21 के corresponding value इसके नीचे दिखा रहा हूं, आप जहां भी दिखाना चाहें. इस 20 के बाद 20 corresponds to this 20. 21 is the pulling force. For this pulling force of friction is 15. Those of you who answered 20 and those who didn't answer anything, if you understand this 15 part, then write down yes in the comment box fast. Good. The moment your force becomes 21, exceeds the maximum static force, body starts moving, and force of friction is what? 15 now. Now tell me this. इस 21 को हमने इंक्रीज किया और अभी ये 21 इंक्रीज होकर हो गया 28. If force of pulling force becomes 28 now, then write down force of friction in the comment box fast. If I increase pulling force from 21 to 28, then what should I write here? Good. It is still what? 15. 28 इसका मतलब बॉडी क्या करने वाली है? मूव. और अगर बॉडी मूव करेगी तो फ्रिक्शन कौन सा यूज होगा? 15. अगर ये 28 किसी ने इंक्रीज करके 35 बना दिया होता, 35, आपका फोर्स ऑफ फ्रिक्शन अभी भी क्या आता? 15. It is not changing. That means what? If you look at kinetic friction, if you look at this part, Fr kinetic, there is nothing like maximum. Fr kinetic is always what? Same. Static friction, you can see it is self-adjusting. Kinetic throughout is what? Same. If body is moving, it will be this much, and therefore we do not use maximum with kinetic. So this is the value of friction when body is moving. This range is when body is moving. Just mention like this. इस पार्ट को रेस्ट करके डिफाइन कर दिया स्टैटिक पार्ट एंड दिस इज योर काइनेटिक पार्ट. तो फ्रिक्शन के क्वेश्चंस को करने का तरीका क्या है? फाइंड आउट एफ आर स्टैटिक, मैक्सिमम, kinetic, and then based on the value of pulling force you can find what type of friction is acting on the body. Write down a statement with this question. The moment pulling force exceeds maximum static friction. The moment pulling force exceeds maximum static friction, body is no longer at rest. Body is no longer at rest. It is moving with respect to the ground. It is moving with respect to the ground, and therefore kinetic friction will act on the body. And therefore kinetic friction will act on the body. This type of question is also asked in schools and competitive examinations in this form. Same thing. Suppose look, if I say that force acting on the body is 5T, where T stands for time. T is what? Time. Everything else is same. Static, kinetic, we have calculated values are same, but it's a time varying force. As you change time, as time increases, force is also increasing. The first question is, at what time this body starts moving? Write down the question. At what time body starts moving? And answer this question fast. You can answer the question in just 3 seconds. And those of you who can answer the question in 3 seconds, they will find that the answer is 4 seconds. Take your time. I'm removing mg and normal reaction. We have found, we've used this information. मोस्ट प्रोबेबली हर आदमी का 4 सेकेंड्स आ गया होगा. Good. Look, FR static max is 20, FR kinetic is 15. The question says at what time body starts moving. When body is about to move. हम इस चीज को कई बार यूज किया करेंगे. About to move. When body is about to move, and in short I will write ATM. ये कई बार आएगा अपने पास टर्म. When body is about to move means at that moment this FR has reached maximum value of static friction. थोड़ी देर पहले हमने किया है कि जब हमारा पुलिंग फोर्स कहां पहुंच गया था 20 पर, तब फ्रिक्शन कहां पहुंच गया था अपने मैक्सिमम पर, स्टैटिक का मैक्सिमम विच इज 20. इस कंडीशन में बॉडी अभी भी किस पर है? रेस्ट. क्यों लिखा हुआ है मैंने रेस्ट? सिंस बॉडी इज एट रेस्ट, दिस फोर्स is balancing this force, but body is about to move. The moment you increase this force slightly from 20, if it becomes 20.00001, the moment this force increases, ये वाले 20s को रोक नहीं पाएंगे, and immediately friction drops down to this value of 15. So the question is, at what time body is about to move? And the answer is when 5t is what? 20, and therefore t is what? 4 seconds. और ज़्यादातर लोगों ने correct answer दिया हुआ है. So when time is 4 seconds, body is at rest, but is about to move. कई बार देखने को मिलेगा ये combination. Body rest पर है, but is about to move. Now, look at the difference between this and this. How will you understand the difference? Same 5 kg body. अगर आपसे बोला गया होता कि टाइम है हमारा 2 seconds, देखना. If time is 2 seconds, then pulling force is what? 5 into 2, which is what? 10. If F is 10, then friction is what? Then friction is FR static. Maximum नहीं बोलेंगे. This is 10. This is also what? 10. This 5 kg body is at rest. बट क्या हम यहां पर ये बोलेंगे कि बॉडी अबाउट टू मूव कंडीशन में है? नो. अबाउट टू मूव इज अ स्पेशल केस. इससे ज्यादा 20 से जैसे ही ज्यादा होगा ये बॉडी क्या कर जाएगी? मूव कर जाएगी. उसके पहले बॉडी रेस्ट पर है, पुलिंग फोर्स और फ्रिक्शन इक्वल है, बट राइट हियर वी कैन नॉट यूज दिस टर्म ATM. और धीरे धीरे क्लियर होगा. अब यहाँ पर not for everyone, there is a homework. Those who are looking for JEE Advanced, the homework is only for those who are looking for JEE Advanced. It's not for NEET, it's not for JEE Main, only for JEE Advanced. In this question, when time is 5 seconds, when time is 5, you need to find velocity of the block. And let's remove confusion from between 5 and 5. Let's take 8 seconds. When time is 8 seconds, you need to find velocity of the object. It's the homework part. Now, there is a class work also. And what is that? Which is something you can expect in your schools and all. And the class work is plot a graph of friction and time. If we plot a graph of friction and time, then how does it look? I'm giving you 30-40 seconds and then I will plot the graph, and if you have done the same thing, then you will write yes in the comment box. So for a force of 5T, you have to plot a graph between friction and time for this block. Let's see how many of you can answer this. Look, how do we plot a graph between friction and time? if t is less than or equal to 4 seconds, body is at rest. If t is less than 4 seconds, body is at rest. At t equals to 4 seconds, you know that body is about to move. Which means for this time, Fr is always equal to what? Pulling force, which is 5t. When time exceeds this 4 second instant, when time is greater than 4 seconds, body is moving if t is greater than 4 seconds, body is moving and Fr has taken a constant value of 15 kinetic friction. जब तक बॉडी रेस्ट पर है, फ्रिक्शन पुलिंग फोर्स के इक्वल है. जैसे बॉडी मूव करेगी काइनेटिक. इसका मतलब अगर आपसे कोई Fr और टाइम का ग्राफ प्लॉट करने के लिए बोलता और यहां पर कहीं 4 सेकेंड्स होता, तो कम से कम आपको इतना पता है कि 4 सेकेंड्स के बाद जो हमारा ग्राफ है, I hope you can see the graph. This is the graph. 4 seconds के बाद हमारा जो ग्राफ है उसमें फ्रिक्शन की वैल्यू क्या चलती? 15. आफ्टर 4, 5, 6, 7, 8 कहीं भी चले जाओ, बॉडी क्या कर रही है? मूव. अगर मूव कर रही है तो क्या लगेगा? काइनेटिक. व्हाट इज दैट? 15. But till 4 seconds, it is F equals to 5t. This F equals to 5t, ये चीज क्या है? अभी उन लोगों के लिए जिन्होंने कोऑर्डिनेट ज्योमेट्री का पोर्शन किया हुआ है मेरे साथ, Fr इसको हमने कहां प्लॉट किया हुआ है? Y एक्सिस. T इसको हमने कहां प्लॉट किया हुआ है? X एक्सिस. 5 as a constant is what? M. Those of you who have not done equation of a straight line, after the class, just send a request and I will give you that lecture. This is equation of a straight line which passes from the origin. So Fr and T graph is of this type. Graph is of this type. This is your straight line part. I hope it's clear. You can see this graph. This is the graph, and in this graph, this is Fr. Corresponding value at the peak of the graph right here is what? 20. at different times, 2 second FR will be 10, 3 second 15, 4 seconds 20. Just after 4 seconds it drops because body is moving and your friction becomes constant, which is what 15. This red portion is gradually rising up, is telling you that self static friction is a self adjusting thing. Kinetic friction throughout is what? Constant. So, if anyone of you have drawn something like this, then write down yes in the comment box. If you have not, there is no issue. Note down everything. Good. बहुत सारे लोग यस लिख रहे हैं. Good. जिन लोगों से नहीं हुआ था, note down everything. जिन लोगों से हुआ है, वो लोग भी write down every information which is on the board. That's how we produce a correct presentation. Time, less than or equal, only greater than sign. Now, many a times you will find that instead of giving two values of friction, static and kinetic, they give you only one value. If it happens, then mu static and mu kinetic, they both will be same for you. If they give you two values, the larger one is static one and the other one is kinetic, but many times to save time, we only provide one value and that value will act as static as well as kinetic. But write down a very important statement. Whenever relative motion is about to begin, remember when I say about to move, it's not this move. You should start what? Relative motion. So whenever relative motion is about to begin, friction reaches its maximum value. Friction reaches its maximum value. Look at this. Now, the whole thing is again laws of motion. Everything which we have done in laws of motion is basically, friction is basically what? A force. So just treat this as a force and you can answer a question like this. We have a 20 kg block. Coefficient of friction is 0.5. I've given you only one. So this is static and this is also kinetic. अब अपने को अलग अलग लेने की जरूरत नहीं है. When M is 2 kg, when M is 2 kg, find out friction acting on the 20 kg block. When M is 2 kg, find out friction acting on the 20 kg block. In just 10 seconds, you can answer this question. But take your time, I'm giving you 30 seconds. Whenever you start solving question of friction, the first thing you need to find is Fr max. अब यहाँ पर हमारे पास static kinetic का मतलब नहीं है, तो simply say Fr maximum. Write down this. Whenever we start solving a question of friction, write down this step and remember this step always. Whenever we solve a question of friction, we always find Fr maximum first. So let's find out Fr max. What is Fr maximum? Mu n. You can always write static, कोई issue नहीं है, लेकिन मैंने आपको क्या बोला, हमने यहाँ पर static kinetic करके नहीं दिया है. अगर कोई 0.5 देता और दूसरा 0.4 होता तब अपन मैक्स स्टैटिक करने की बात करते, एक ही है इसलिए forget about. Mu is what? 0.5. What is normal reaction? इस 20 kg की बात हो रही भाई, नीचे क्या लग रहा है इस पर? mg. कौन है इसको जो बैलेंस करेगा? n. सिंपल है, n is what? mg, which is 20 into g, which is giving us 100. अब ये लोग क्या करते हैं? Once you see 100, they write Fr as what? 100 only. Well, that's not the correct thing. Why? ये जो m है, अब इसको देखना, इस पर नीचे कितना लग रहा है? 2g. This m is 2. अब अगर ये 2g है, यहां क्या डेवलप होगा? टेंशन फोर्स T. What is 2g? 20. It gives you an idea कि क्या होने वाला है. यहाँ T है, हर आदमी को पता है कि यहाँ पर भी क्या होगा? T. टेंशन फोर्स कहाँ लगता है? Away from the body. Away from the body. Away from the body. Now, इस पूरे सेटअप को देखना, अगर आपने इस m को 2 kg लिया हुआ है, तो डाउनवर्ड फोर्स क्या आ रहा है यहां पर 20। ये 20 न्यूटन फोर्स है, T इसे अपोज कर रहा है। थोड़ी देर के लिए हमने इस m को किस पर लिया, रेस्ट पर। स्टार्टिंग में आप क्या लोगे, चीजों को रेस्ट पर क्यों लोगे, क्लियर होगा अभी। पहले अगर इंफॉर्मेशन नहीं है अपने पास तो हम क्या करते हैं, हम चीजों को रेस्ट पर लेते हैं। अगर रेस्ट से हमारे पास सही आंसर नहीं बनता है, देन हम उसे काइनेटिक पार्ट की तरफ लेकर जाते हैं। क्या बोल रहा हूं मैं, अभी क्लियर हो जाएगा, देखते जाओ। वी टुक दिस m or 2 kg block at rest. If this is at rest, then immediately it tells us that T, this rest, it tells us that T should be 20. M is not moving. T is 20. या तो ये मूव करता या रुका रहेगा। अगर T 20 है तो यहां आए। What is T 20? अब अगर ये 20 है तो ये तो पुलिंग फोर्स है। इस 20 kg को कितने लोग खींच रहे हैं, 20। और इस 20 kg को रोकने वाले कितने हैं, 100। तो क्या इसको रोकने के लिए इस तरफ 100 आने चाहिए, आपको पता है नहीं, ये तो मैक्सिमम है एंड दे आर क्वाइट लेजी। तो फिर इस FR की वैल्यू क्या होगी, 20। दिस इज 20, दिस इज 20, इसका मतलब ये वाला 20 kg मूव नहीं करेगा, ये किस पर रहेगा, रेस्ट। इज इट पॉसिबल, यस। ये बॉडी अगर रेस्ट पर है तो ये भी क्या रहेगी, रेस्ट पर। आंसर, तो जब मास कितना था 2 kg, उस वक्त FR क्या था अपना 20। दिस इज द फर्स्ट पार्ट। अब जरा समझना, थोड़ी देर के लिए समझना। सपोज अगर हमने इस 2 kg पर सपोज ये अज्यूम कर लिया होता कि m, this block is moving, it's coming down. Listen again. This 2 kg block, if it were coming down, then this 20 kg will also move. And if this 20 kg moves, तो फिर हमारे पास बॉडी पर क्या लगेगा, काइनेटिक फ्रिक्शन। हमारा फ्रिक्शन की वैल्यू जो है वो क्या चल रही है, 100। विल कीप इट एज काइनेटिक ऑल्सो। तो अगर ये चीज मूव करती तो पीछे की तरफ क्या लगने लगता, 100 न्यूटन। और यहां कितने लोग खींच रहे हैं, 20। और इधर कितने लोग खींच रहे हैं, 100। इज इट पॉसिबल कि 20 लोग खींचकर नीचे ले जाएं और रोकने वाले 100 हो यहां पर? यू नो दैट इट्स नॉट पॉसिबल। दैट मीन्स कि ये जो ब्लॉक है ये किस पर रहेगा, रेस्ट पर। अभी भी अगर ये क्लियर नहीं तो परेशान मत होना, क्यों? क्योंकि इस नेक्स्ट पार्ट से, इसी क्वेश्चन के, ये पूरी चीज क्लियर हो जाएगी। सेम सेटअप। और ये जो ब्लॉक है हमारा m, this was 20, this m, it's been given that this m is now 30 kg. What is m? 30 kg. Find out friction which is acting on the 20 kg block. Try to answer this. If instead of having 2 kg block, you have a 30 kg block, then what is friction acting on the 20 kg body? Good. That's what is expected from you, from those. Good. And if you, once things are clear, friction is very easy and elementary part. And that's the reason within 10 seconds many of you answered this. Now look, let's use the same logic. Those of you who found this part little bit difficult, pay attention to this thing. What is downward force? 300. Let's save time. mg. 30g. What is 30g? 300. This is T. This is T. Friction will be acting in this direction to oppose this. Suppose somebody says that this block is still at rest. Suppose you somehow took this assumption that 30 kg is at rest. कोई इशू नहीं, मान लिया हमने. अगर हमने गलत assumption लिया हुआ है, physics automatically हमारी क्या करेगी? Help करेगी. So this is 30 and you keep it at rest. Then this T to balance 300 should become 300 itself. 300 ने 300 को कैंसिल किया, बॉडी किस पर है? रेस्ट पर. लॉज ऑफ मोशन बोलता है कि अगर ये T है तो ये भी T होगा, विच इज व्हाट? 300. बहुत सही. फ्रिक्शन क्या बोलता है कि इस 20 kg को खींचने के लिए कितने लोग हैं? 300. और रोकने के लिए कितने लोग हैं? मैक्सिमम 100. इसका मतलब इस 300 को रोकने के लिए हमारे पास मैक्सिमम कितने हैं? 100. क्या ये रोक पाएंगे? नहीं. इसका मतलब ये 20 kg क्या करेगा? मूव. लेकिन आपने यहां क्या लिखा हुआ है? रेस्ट. ये रेस्ट पर है और ये मूव कर रहा है. Is it possible? No. And therefore this is something which is not possible. A big no. First tell me, are you comfortable with this concept that I took 30 kg block at rest and then I proved that this assumption is not correct. Are you comfortable with this? Yes or no? First. कि हमने 30 kg को पहले तो किस पर ले लिया? रेस्ट पर. एंड देन जब हमने डेटा यूज किया तो मालूम पड़ा कि ये 300 है, रोकने वाले 100 है, रोक नहीं पाएंगे, ये मूव करेगा. ये मूव कर रहा है, ये रेस्ट पर है. नॉट पॉसिबल. देन व्हाट? हमने बोला एक काम करते हैं कि भाई ये जो अपना ब्लॉक था इस पर नीचे क्या लगा? 300. ऊपर क्या लगा? T. अब देखते जाना. अगर ये रेस्ट पॉसिबल नहीं है, दिस इज 30 kg ब्लॉक. आई होप चीजें दिख रही होंगी. दिस इज 30 kg, दिस इज 300, दिस इज T, this is T and this is your 20 kg block लिखा हुआ यहां पर. अब अगर ये पॉसिबल नहीं है, इसका मतलब 30 kg क्या कर रहा है? मूव. और अगर ये मूव करेगा तो ये भी क्या करेगा? मूव. और जैसे ही बॉडी क्या करेगी? मूव. इस पर पीछे की तरफ क्या लगेगा? फ्रिक्शन. नॉर्मली अपन क्या लेते हैं? काइनेटिक. लेकिन अभी हमने क्या बोला हुआ है कि ये जो अपना मैक्सिमम है, अब यही हमारे लिए क्या बन जाएगा? काइनेटिक भी. 100 100 100. तो फिर जो फ्रिक्शन है वो क्या बना रहेगा? 100. सपोज इन्होंने काइनेटिक की वैल्यू कुछ दे रखी होती, काइनेटिक आ रहा होता 100 से कुछ कम 80, तो हम क्या यूज कर रहे होते? 80. बट सिंस दे हैव गिवन अस दिस 100 ओनली, blue arrow, it shows that since block is not at rest, is in motion, if it is moving, friction is maximum, which is what? 100. And now you can also find acceleration. Let's see how many of you will give me the acceleration of the system. With what acceleration the whole thing is moving? Write down this fast in the comment box. With what acceleration this whole thing is moving? Write down this. और याद करो हम लॉज ऑफ मोशन में क्या ट्रिक यूज करते थे. इफ यू यूज दैट ट्रिक, तो फिर ये एक लाइन की चीज है. देखना इधर. थर्टी kg, नीचे क्या लगा 300. डाउनवर्ड एक्सेलरेशन A, दिस इज T. यहां से टेंशन इज T, लेकिन अपार्ट फ्रॉम दिस T you also have a force in this direction, force of friction, which is 100, since body is moving with acceleration A. What is the equation for this? 300 minus T is mass into acceleration. What is the equation for this? T minus 100. T minus 100 is mass into acceleration. ये था प्रॉपर तरीका. मैं आपसे क्या चाहता था, अगर ये ऑब्जेक्टिव प्रोफाइल में आएगा तो फिर ये पूरा फिगर इसके इक्विवेलेंट है. If they give you this whole thing in an objective question, then as a trick, you can use this. What is the trick? 30, 20. इस 30 को कौन खींच रहा है? 300. इस 20 को कौन रोक रहा है? 100. और ये पूरी चीज इधर जा रही है with what acceleration? A. So how do you write the equation? Equation is this: 300 minus 100 is what? Mass. How much mass? 30 plus 20, 50 into A. Which is nothing but this equation plus this equation. When you add this and this, T and T gone. 300 minus 100, 20A, 30A, 50A. But when I draw this figure in this form, what I am saying is this tension force, you can forget this tension force because it is behaving as if it is an internal force. So you can remove this T and T in this form. In schools, if they ask you this thing in subjective version, write down this equation, add, and you'll get the answer. Now those of you who are comfortable with this shortcut, write down yes in the comment box. If you are comfortable with this. And if you are not, then it's a request, go through laws of motion lecture once again. We have done these things there. Look here. M, and on top of M you have another M. Coefficient of friction is mu. Coefficient of friction is 0. You have block of mass M. Friction is present between M and ground. On top of this M, you have another block of same mass. There is no friction between these two. Force F1 is acting in this direction. Second setup, M. This is mu, this mu is 0. A force is acting in this direction, F2. इसको हमने कहाँ रख दिया, आगे रख दिया। म्यू कितना चल रहा है, 0. This is F1, this is F2. You need to find minimum force, minimum value of F1, so that this system and these two systems can move. You need to find minimum of F1 so that it can move. You need to find minimum of F2 so that this system can also move. And just so that you can answer it, you can take the value of mu as 0.4 and take m as 10 kg. So that you can produce a numerical value. Mu is 0.4, mass is 10 kg. Find out F minimum, F2 minimum. Before that, just tell me which option is correct. If I want to move this, then F1 equals to F2, F1 is greater than F2, or F2 is greater than F1. Which of these three options you think is the correct one? A, B, or C? Before you're answering or finding values of F1 and F2, just by intuition, कि अपने पास कुछ भगवान ने कर दिया हो, अपन विजुलाइज करना चाहें, तो do you have that kind of visualization or not? किस केस में आपको कम फोर्स लगाना पड़ेगा चलाने के लिए? That's what my question is. Good. बहुत सारे लोगों ने सही आंसर दिया हुआ है. And the correct answer is B. ये M इस M के ऊपर रखा हुआ है. केवल numerically we'll solve this thing in the next class. Right now केवल feeling develop कर लेते हैं. इस M के ऊपर आपने एक M रखा हुआ है, which is like you have a truck. और इस ट्रक के ऊपर आपने सैंड फिल कर दी, बहुत सारा कुछ लगेज रख दिया, बहुत सारा सामान रख दिया, तो फिर ये ट्रक क्या हो जाएगा? हैवी. आप इसे मूव कराना चाहते हो. ओके, दिस साइड आपके पास वही ट्रक है, लेकिन आपने उस ट्रक के सामने सारा का सारा मटेरियल रख दिया, but on a surface or on a trolley which is completely frictionless. Try to visualize this. ट्रक को आप हैवी बना रहे हो, यहां फ्रिक्शन बढ़ जाएगा. इस ट्रक के सामने रख रहे हो, यहां का फ्रिक्शन वही है, इसके सामने आपने रखा हुआ है, and this part is completely frictionless, and therefore इस चीज को पुश करना relatively easy होगा, as compared to this. Now try to find F1 and F2, and then we'll see this part in the next class. Thank you very much.